Okay, so in this video, we're going to take a look at, once again, how logarithmic and exponential functions are inverses of each other, meaning the x's and y's in them, the inputs and the outputs switch. So first, the table here, and to put it together, we're actually going to rely on the graph, which was shared previously at the top of this file. If you click on that Desmos link, that takes you here. And what the graph's showing, that diagonal line caused by y equals x. Any corresponding point on the exponential, which is the blue curve, is going to pass through that line perpendicularly and hit a corresponding point that the values are the same. Just what was x and y on the exponential becomes the opposites on the logarithmic. And if I increase that line, so if I play around with the slider a little bit and get it to be right there, there's 0, 1 on the exponential, which corresponds to 1, 0 on the logarithmic. So what should be becoming very clear at this point is whatever's x and y on the exponential becomes yx on the logarithmic and vice versa. So when we go back to the file here, I'm looking for where does 2 happen on the logarithmic. It's now in the output or y position. And I know that x and y is listed here the way they are, but the 2 goes with the 100. And then now here's 11 on the logarithmic. Where is it on the exponential? Right there. It goes with 1.041. And kind of the last piece of making sure you're correct here, as the x's are going up. So as the x's go up, the y should also go up. So, same thing on the logarithmic as the exponential. The x's are going up, they're increasing. It's not a big increase from 10 to 11. So the y increase, the output should not increase by much. And now, same overall idea here, 0, 1 would become 1, 0. 1, 3 would become 3, 1. 2, 9 would become 9, 2. And 327 would become 27, 3, right about there. Now, if I draw not super awesome, but close curves that hit these points, there's the logarithmic. Here's the exponential. And here's my line y equals x, which is truly telling us, hey, anything that was y on one becomes x on the other, and anything that was x on one becomes y on the other. And when we go across, they're going to hit that y equals x line at approximately a 90-degree angle. They're going to be about perpendicular, especially if I drew slightly straighter. And just kind of going back and trying to check this on Desmos. I screwed this up in an earlier attempt. If I drag those to right, and to get to 3, 1, which is close to there. Now I got to go a little further. And our base needs to change to 3. That's why I was having some trouble with that. Okay, if I bring this back some, so right about there. There's that confirmation. Hey, 1, 3 on the exponential corresponds to 3, 1 on the logarithmic, because in both cases, our base, it's 3 to the x, or our base here is again 3 to base 3 getting to whatever value. There's confirmation that we're actually correct because I've set both the log and the exponential to base 3. So hopefully this helps a little bit. Ultimately, what is x and y on an exponential switches spots on a logarithmic, and whatever the xy is on the logarithm, like 9, 2, switches to xy 2, 9 on the exponential.